Okay, yo, rough night trying to make videos tonight, man. Lost, forgot to turn on the microphone on the other two videos. That looked pretty good. Just finished recording the experimental design one. That was honestly pretty terrible for my, third try, but it's late, so let's just get one up there, okay? A lot of you don't even need the note video, so it is what it is. I'll make better ones next time, promise, okay? Anyway, for those of you that were struggling on this making measurements mini lab, let's just walk you through it, okay? So we started this after the quiz on Friday. I'm really hoping that you made a hypothesis of some kind. Now that you have some notes on writing a hypothesis, you could change it if you want. Not a big deal. If it's wrong, I'm not going to mark you down for it, okay? You should have this part filled in with some information from what you did in class. Hopefully you got it from a partner. If you didn't, some people talk to me. I let you take some materials home. If this part is blank, you're not going to get full credit. I'll probably give you an incomplete. Okay? So here's the thing. These discussion questions. Let me just kind of rehash what it is that I talked about in class today, just in case you weren't paying attention. It was the end of the period and you were tired, whatever. All right? So first off, it says find a group that measured the same object as you. Was it the same? Chances are it wasn't. That's sort of what we're looking for. It probably wasn't the same. First thing, a lot of groups, they didn't even use the materials I gave them. They tried to think outside the box, which is totally fine for this one. They tried to get creative, and they were like, oh, I used my height to measure the table. Great, except the table's probably not exactly what your height is, so you had to estimate a little bit. I used this 8.5 by 11 piece of paper. Oh, this is my kid's reading now. Hello. 8.5 by 11 piece of paper. And with that piece of paper, I know that the side is 11 inches, and we can measure the table. Chances are the table is not a multiple of 11 inches long, or 8.5 inches long, so that probably doesn't work either. So what we can agree on is that some level of estimation probably had to happen when you guys were recording, when you were, recording your data. Okay? If you did it the way that I wanted you to, you used the straws and the paper clips, and you measured using units of straws or paper clips. The problem with that was not all groups had the same straws. Some were longer, some were shorter. Not all groups had the same paper clips. Some were big, some were small. So reasonably, you would expect that chances are the group that you compared your data with would not have the same measurement as you. So it's not because you're poor at measuring, though we will find that you probably aren't the greatest at measuring during the first couple labs. It's not, I'm not trying to make fun of you. Just you guys need to practice on it, and that's why we do a science lab, okay? So, yeah, chances are you're not the strongest, but that's not why your measurements weren't the same. It's just because I gave you improper tools, kind of on purpose, non-standard ones. All right? For the difficulties you had, that's up to you. I don't know what you experienced. You just, tell me what your experience was. Read it. I'll go for it. All right? Now, the main thing is this number 3. This is the part that I'm really going to look at deeply, that I really want to grade. I want to make sure that you are understanding how to use claim-based reasoning. That was the big part of the quiz. We've been talking about this for a while now. You have to do claim-based reasoning on every lab, probably some part of every single quiz. You need to understand how to support what you are saying with evidence, okay? So in this one, it's saying, why is a standardized system of measurement necessary in science? So we're not using straws, we're not using paper clips. We would use the metric system, or more specifically, something called the SI unit of measurement, okay? The difference between SI units and the metric system is it includes the Celsius for temperature. It's not really a metric measurement. I believe it uses pH also, okay? So those are the 5 main ones that we care about, all right? We care about length, volume, mass, temperature, and pH. All right, so let's go through this as a general idea. Okay, our length, we're going to use the meter. Generally in science, it's smaller, or what we study, it's smaller, so it'll probably be the millimeter or the centimeter. Okay, volume, we're going to talk liter. Generally in science, in our class, it'll be milliliters though. Mass, we're talking gram, probably gram. Okay, our scales only go to the decigram for the most part. I have one that goes to hundredths of a gram, but yeah, they're not super accurate, so it is what it is. Yeah, we'll talk Celsius later, and we'll talk pH way later probably, all right? So we just care about length, volume, and mass right now. All right, so here's the idea that I was throwing out to my classes. Let's say you're a doctor, right? And you don't have standardized measurements. If you don't have standardized measurements, then what you end up doing is, let's say we use paper clips. So you're going to do like open heart surgery, and you're going to be like, all right, I need to go like 4 paper clips in to get to the heart. So what are you going to tell the nurse? I need 4 paper clips. And the nurse is like, the big ones, the small ones, which one? They just hand you some stuff, and then like you kind of go for it, right? Let's say 4 paper clips is this big for small ones, and then it's like, I don't know, that big. Oh, it's a Yoda hand. Okay, this big versus like this big for the other ones. That's probably a big difference. You're gonna totally miss the heart or something like that. All right. So logically speaking, in science, why is it that you would want to make sure when you're measuring a millimeter that it always is a millimeter? Like a millimeter is the same distance no matter what. Why is it that we care for, I don't know, if you need to boil something to 75 degrees Celsius, that it's always 75 degrees Celsius is the same measurement, and it's not you just saying, pretty hot, kind of hot, lukewarm, tepid, like we need to have an actual temperature associated with it. So why are those things important to have in science? It's pretty much what we're asking. All right. My terror of a son is coming, so I'm going to stop this video. Hopefully that helps. But yeah, I'm collecting this thing tomorrow. Hopefully you have the answers down and, some very simple CER stuff for that number 3. Whew. Okay. Goodbye. Oh my God. Let me stop. Okay.